Alright, so let's review GCF and LCM using prime factorization. First of all, before we even begin, what is prime factorization? What is it that you're trying to do when you do prime factorization? Because you got to kind of put it into words what the whole goal of it is. What's the point of it? Does anybody care to respond? See, we don't even know that, do we? What are you doing when you're doing prime factorization? Hunter. Okay, you're breaking them down into factors, but what kinds of factors? Prime factors. So if I give you a number, and we'll see the next page, we're going to do one together. I want to know what that number, whatever that number is that I give you, I want to know, if I break that number down, what are the prime factors that we can multiply together to make that number? That's the purpose of prime factorization, which we need to do first before we do GCF. Okay, so, kind of like what Hunter said, the whole goal or purpose of prime factorization is we're breaking down numbers into their prime factors. Let's write that down. And if you're hung up on what the word prime factors means, prime numbers, again, are numbers where the only number that goes into that number is 1 in itself. And a factor just simply means a number that can't be multiplied. Okay, so we're going to do 32 together. I have my actual factor trees and leaves here. Christina, if you can get the lights turned off, because I want you to tell me why some of these leaves are green and some are red. See if you can figure that out. The leaves, the little leaves here at the bottom, why are some red and some are green? Kurt. Right. Right. So it's kind of like a little visual aid, I guess, because whereas you can't color code, you're going to circle your prime factors. Here they're in red. So, starting with 32, give me any two numbers that when multiplied together make 32. Alex. 8 and 4 will work, right? What else would work? 16 and 2. Anything else? In this case, I don't think so, right? Alright, so we'll start with 8 and 4. You're going to do lines, I have branches. Both of them, notice, are composite because they're green. So don't circle them on your end. It doesn't matter how you start off your factor tree, you'll always wind up with the same circled prime factors at the end. So if you start 8 and 4, or start 16 and 2, you'll still wind up with the same circled prime factors at the end. Doesn't matter which one you break down first. What do you want to do, 8 or 4? Alright, we'll do 8. Give me two that make 8, hon. No. 2 is prime. Circle it on your end. And hon, finish it up. 4 for 2. 2 for 4, I mean. Both prime, circle it on your end. Forgot what my original branch were. Okay. And that, 2 for 4. 2 and 2. Alright, you see it? Okay, here's where you guys got hung up on weekly reviews. There's a line underneath, right? You didn't know what to do with the line, and I had to kind of coach you through it for the last 3 or 4 review sheets. The way it works is, let me see if I have an actual line for that. I don't know if I do. Alright, I'll stay on this page. You have the line, right? I don't? Okay. I'll make a line here. I put it here just so you know what to do with it. Okay. You take that number 32. You actually write it down. 32 equals. What prime numbers when multiplied together make 32? Okay, so rattle them off. That's that's what you're supposed to do on that line. Because now you've shown me that 32, its factors, or its prime factors, are 2 times 2 times 2 times 2 times 2. You multiply those together, you'll get 32. What makes these numbers unique is they're always prime numbers. They don't happen to all be the same this time, but as you'll see, they won't always be the same. Now, something new that I did not teach you when I taught this to you, because we have since done it. How would you rewrite this in exponential form? Yeah, Lou. Put that in parentheses. If you can do this when you do prime factorization, that's pretty cool, because then you've incorporated 2 different skills. However, when you do GCF, leave it in expanded form, because you're going to need to cross out these numbers as you do GCF, as you'll see on the next page. All right? So this is called prime factorization. With GCF, it's prime factorization, but you're going to do 2 numbers. By the way, before we do GCF, let's just do prime factorization again. On your own, do 75. Is there room on that front? If not, you can do it on the back. I think, is there blank on the back, or is there writing on the back? Okay, so just do it off to the side. I think there's room. And I'll call you up. Alright, so I want to come over. Now, when you come up, use your knuckle to drag the wheels. It's easier rather than using your finger. Jack choice. By the way, the branches here are these right here. Those are on. Yeah, use your knuckle. It'll go. It actually grab it. Keep going. There you go. Did anybody start out differently? Anybody do 25 right? Watch, you'll get the same prime factors again. You wind up with 5, 5, 3. Wait, Jack, you're not done, bud. Now to the line. Now, can I make a suggestion to you? Don't do it. Just write your 75 equals. When you list your prime factors, it's going to make it easier if you list them and multiply them in what we call ascending order from the least to the greatest. You'll see it will come in handy when you do GCF. Starting with the lowest number. Good. Dot. That's it. Okay? So start with the lowest number and build up. It's going to make it easy when you do GCF, as you'll see. Okay, let's go on to GCF. What is GCF? What are we doing? We know it means greatest common factor. What does that mean in your own words? When you find the GCF, what is it that you're finding? 10. That's it. 2 or more. It's the greatest number that will go into both of those numbers. And it can be more than 2. I've given it to you with 2, but you can do 3. When you do greatest common factor, it doesn't necessarily mean that your GCF is going to be a prime number. It can be, but it may not be. You'll use the prime numbers to get the GCF, but your GCF itself can be prime or composite. So let's do 60 and 144, which is my next page. You got to kind of write small. It's a little tight between the line and the number, so don't write too big. When I taught this, I taught it several different ways. I taught it using prime factorization, but then I used long division, what's called the algorithm. I like prime factorization better because it will automatically work for LCM as well. As a matter of fact, next year when I teach it to the 6th graders that are coming in, I'm not going to show them the algorithm with division. So I think that's where the hang-up was. You need to practice prime factorization because then it becomes easy to do LCM right after that. Pilot. 2 for 60, bud. Get ahead. What do you got? All right, 20 and 3. What else could you do if you didn't do 20 and 3? 12 and 5 or 30 and 2 or 10 and 6. Lots of different ways to go. You'll always wind up with the same. Which, if any, are prime, Tyler? Circle it. 2 for 20. Good, do it. Which, if any, are prime? Circle it. 2 for 10. Which, if any, are prime? Okay, 60 is done. Give it to me now. 60 equals. Good, you remember to put it in ascending order. Alright, 144. Tree, give me 2 for 144. Write small because you're going to need space. It's tight. And 7, not quite okay, 84. Take a breather, we'll come back to this. In the meantime, Tree, think about it. Tree has left the building. Anybody that knows two numbers that when multiplied together make 144, please raise your hand. Good. Sounds good to me. Neither one are prime, right, Kurt? Break down 12. Who has less? Alright, you guys have to come back after you're done. I gotta give you this for the sheets that you're missing. We're never gonna get this problem done because every time somebody gets it started, they leave. Tree's gone and now Kurt's gone. Which one's prime? 6 and 2. Break down 6. Okay. And look, you have no problem with me just copying the same circle numbers because it's the same number. Hold on a minute. This was yours the last time I checked, right? All right, 144 equals. Rattle them off. Make sure you get all of them.
3 times.
Give it to me in ascending order.
2 2.
Okay. So now that you have prime factors for each number, this is why it makes it easier when you put both of them in orders from least to greatest. Look on your 2 lines, and if you see a number that's in both, cross it out once. Cross it out on in each tree and list it only how many times? 1 time. So cross it out, and list it once. Followed by a multiplication sign, because you need to multiply your common prime factors together. I see another 2. Cross it out, list it once. Now we're out of 2s, but we have a 3. Anything else? That's it, right? You have a 5 here, no 5 to match it up on the other one. So now multiply 2 times 2 times 3, and what do you get? That's your GCF. That's telling us that 12 is the greatest number that will go into both 60 and 144. By the way, 12 goes into 60 how many times? 12 times 5. 12 goes into 144 how many times? You got it. What's LCM? So, go. Right, it's the lowest number that both, in this case, 60 and 144 can go into. It stands for lowest common multiple. Least, lowest, least, same thing. Lowest, least common multiple. So it's really the smallest number that both 60 and 144 can go into. So your thinking automatically has to be that no matter what, the number's got to be 60 or more. Okay? And as a matter of fact, it's got to be 144 or more too. So don't think small with this. You're not looking at numbers that are like around 12, 15. It's got to be only think about 144. There's nothing smaller that 144 goes into. So the number's got to be at least as big as 144. All right? Right, because 60 won't go into 144. So the way that we're going to show how to do that is we're going to build off of our GCF and our factor trees. Let me finish this definition first. And here's how you do it. Half the work's done. You've done your prime factorization for both 60 and 144, plus you've found the GCF. It's the GCF times the leftover numbers. Leftover numbers are the ones that are not crossed out. So as you recall, what was the GCF? It's 12. Look back at the numbers that are not crossed out, the prime numbers that are not crossed out. And rather than me scrolling back and forth, what's not crossed out? And here, by the way, if it's in both trees, although it shouldn't be, because we did GCF, every time you see it, you list it. Give it to me again.
2.
2, slowly, plus another 2,
Yeah.
plus, or times, another 3.
Yeah. 5.
That's all of them, right? I'm going to go check. I want to make sure. Got the 5. And 10, 2, 3. All right, multiply it together, but use mental math, because if you do this correctly, you can do it all in your head. 2 times 2. 4 times 3. 12. 12 times 5. Right, now ready? Got 60, right?
Yeah.
You can do 60 times 12 in your head, because you can do 6 times 12 in your head. Just add 0. 6 times 12, add a 0. 720. Like I told you, remember when you think of LCM, think big. 720, believe it or not, that's the lowest number that both 60 can go into and 144 can go into. There's nothing smaller. 60 goes into 720. How many times? Bet you can do that. You just did it 12 times. What about 144? You know it's got to be an even number. Start thinking what could be reasonable. 144 times what? 5. Okay? I know, it's right here, this little test. Okay, so now we're a little short on time. So here's what you're going to do, guys. Priority is going to be the exponential less. This is going to be graded. Okay? Then, on loose leaf paper, you have to do these 8 problems from GCF and LCM. It is time consuming. It's going to take you about a half an hour to do all of them, to do them well. Right? Do them on loose leaf. No guessing. I don't want you to do it in your head. If you want to kind of guess in your head what you think GCF is or LCM, that's fine, but then back it up with factor trees to see to prove that it's right. But for now, start with this. No calculators. This is the exit ticket for less number. You start with this.